You got it? Okay.
Well, welcome everybody. We are going to start a little bit early, so thank you those that were able to hop on early as we open up the room uh, prior to what we expected. But we're happy to have everybody here. As you keep hopping in, let us know where you're from. If you want to know if you want to let us know your current temperature of where you're living, we're about 15 degrees here in Iowa. But thank you again, everybody, for joining us here for our last webinar here in 2025. But we've got much more to come in 2026. And for those, I know a lot of you. This is going to be your first time attending a Tree Fund webinar series. So welcome and thank you. Tree Fund is Tree Research and Education Endowment. We are proud to be able to support the researchers and the research that happens in this form and fashion to give back and to let our researchers like Stella D here be able to let you into what she's learned and what she's discovered and get the information to a wider audience. Uh, we want to thank our Crown and our Platinum sponsors. This webinar series is free. We want to make sure that we're able to offer these wonderful opportunities to you all around the world for free. And so we greatly thank all of our partners, and including our Crown and our Platinum partners here. And thank you to Bo for helping to host this webinar uh, every month almost. For those that are here for CEUs, when you logged in, when you registered, all of your CEU information has been recorded. So you no need to let us know your ISA information. That will get submitted directly from Tree Fund to ISA on your behalf at the end of the presentation. So just make sure that you stay on and watch the entirety of it, and all of that will be sent to you. If you need a certification of attendance, please email education@treefund.org, and we'll get that to you in the next week or so as we're able to. And then lastly, all of our webinars this year, they have been submitted to ISA for accreditation. So if you did attend the entirety of a webinar and you have not seen that CEU pop into your ISA account, please let education@treefund.org know, and we will get that squared away. As we look forward to 2026, we've got some things set in place and quite a few other things that are still working in behind the scenes, but we will have a webinar in February, March, and April. And registration will be coming shortly as we get some of that additional information tied up. Next, I want to introduce Paul Putman. He is our president and CEO of Tree Fund.
All right. Thanks, Heath. Hopefully I'm not having an echo on people's computer as we get started. So I wanted to say good morning, good afternoon, and good evening, everyone, and welcome to today's webinar, which is hosted by Tree Fund. Big thank you, as Heath mentioned, to our Crown and Platinum partners that you saw on the first slide. We're also thrilled to see such a diverse group of arborists, researchers, and tree care business owners joining us from around the world. And as a reminder, at Tree Fund, we're committed to advancing research, education, and awareness surrounding the importance of trees in our communities. I want to take also a quick moment to thank both Heath and Bo for their work with this webinar series. This is something that many of us enjoy seeing throughout the year, and there's a lot of work that goes on behind the scenes, both technologically and logistically, in arranging schedules and things like that. So thank you, Heath and Bo, both of you, for this. Before we begin today's webinar, we wanted to spend just a few minutes talking about Tree Fund. So we're a nonprofit or non-governmental agency, and that means that our budget is not supported by the US government on a regular basis. In fact, as many of you know, the US government actually cut support for research during 2025. Tree Fund this fall processed nearly 300 research grant letters of intent and well over 100 completed grant applications. That's an increase of over 300% over the last few years. We do not have nearly enough to fund all of the qualified projects in arboriculture and tree care that are submitted. But with partners like Osplund, which will update you on an announcement very shortly. We continue to build the Tree Fund Endowment that funds the research. We're proud to be, in the words of our Research and Education Chair, Andrew Koser, one of the most steady and consistent sources of funding for arboriculture research out there. But keep in mind that those funds are specifically designated to fund the research, not the daily operations of Tree Fund. We need the support of individuals like you to keep Tree Fund going. So I want to be honest at this point. This has been a tough year for Tree Fund and other nonprofit organizations in the US. We have an annual appeal goal of $40,000, and we need your help to make it happen. We understand that other organizations charge a fee for their webinars, and that helps them manage their costs. But the Tree Fund Board of Directors, which oversees our organization, is committed to keeping these webinars free and open to everyone. But to do that, we need your support. You can support us not only by attending the webinars and telling your friends and colleagues about them, following us on social media, we also need your financial support. You don't have to be a millionaire to support Tree Fund. If these webinars are meaningful to you, if you value the research being funded to bring you cutting-edge information on safety, urban tree care, arboriculture, we're asking you to join us today as a Tree Fund donor. And we're not asking you to do anything that we're not doing ourselves. So last December, I challenged webinar attendees to donate, putting up $500 personally to match your donations. And thanks to webinar participants like you, we raised well beyond that match. Thank you to everyone who donated then or throughout the past year. Then if you'd like, please share in the chat why you have supported Tree Fund. What does Tree Fund mean to you? What do these webinars mean to you and your practice? This year, the Tree Fund board is getting involved. You see their smiling faces on the slide right now. Every dollar donated during this webinar will be matched up to $4,000. So during this webinar, if you're able, we're asking you to perhaps donate $26 to celebrate 2026 in the schedule ahead, or choose $25 or any amount that's meaningful to you. Again, for every donor who gives today, the board and I will personally match your donation up to $4,000. That means if you give $100, we will match that, so it's like your donation is $200. Over the past few years, we've had thousands of participants like you. If everyone who tunes into our webinars donated just a few dollars, we'd be able to expand our reach, maybe even add in a new grant program. Think about how many webinars you've personally attended. What have they been worth to you? Is it 25? Is it 50? You can support the work of Tree Fund through this QR code or by clicking on the link that Heath is putting in the chat. There's an option on the web form for recurring donation. These gifts are tremendously meaningful. If you're able, a gift of $5 or $10 a month goes a long way to supporting our work. Everyone who donates does get a receipt and a thank you for their support. So thank you so much for your consideration and support of this request. So at this time, I'm pleased to introduce Chase Osplund, who is Director of Operations for Osplund. Chase is going to share some news regarding the Hyland R. Johns Endowed Research Fund, which is the fund that supported the research being shared today. We're thrilled for their partnership. Chase has spent more than 2 years at Asplund supporting field operations across the Midwest and Appalachia on investor-owned and cooperative utility systems. He has nearly a decade of experience in infrastructure development, operations management, and technology deployment. Chase supports Asplund's industry engagement efforts, including Tree Fund, to advance the standard and professionalism of utility arboriculture. This promises to be a truly insightful and enriching session, and we're excited to have all of you here to be a part of it. Once again, thank you for your continued support. And with that, I will turn it over to Chase. He can turn his camera back on. I think he's still...
Yeah, Paul, you should be able to, hopefully everyone can see
we
me.
can certainly see you. Yep. All right. Thanks, Chase.
Okay, great. Thanks, Paul. Yeah, I just want to speak briefly about the importance that Asplund holds the Tree Fund in. Our industry is the core part of our business, and we know that the slow accumulation of knowledge, the old concept in research that we stand on the shoulders of giants, the slow accumulation of the different pieces of both basic science and applied science in arboriculture are really important to the outcomes of our business and our industry, and obviously the health of trees and of our planet as well. one thing we're very proud to do at Asplund is, especially as Paul said, there's been some challenges with regard to research funding, especially recently, is to endow a $500,000 fund for the sponsorship of for grants for research sponsorships for applied arboricultural research. And this is called the Hyland Johns Grant Program. Hyland Johns was an employee of ours who worked in technical services and a lot of training, a lot of kind of keeping the company in tune with the cutting edge of arboricultural research, all the way from the 1970s through to the early 1990s. He was a key part of some of the big long-term projects that are often talked about at conferences, and such as the PA State Game Lands Project and other projects. So we're very proud to honor him by naming the research program after him. And also to support the Tree Fund and all the research that's going on in the industry and in the biological and arboricultural sciences. So it's an honor to be able to do that and to fund an endowment for more research in our industry. And I guess now get the privilege of introducing our speaker, which is Stella today. Stella is a PhD candidate supervised by Dr. Brian Kane and working as a research assistant at the Woag Auditorium at University of Massachusetts at Amherst, where her academic research examines the efficiency of arboricultural practices, including cabling, bracing, and pruning. She's an ISA certified practicing climbing arborist with almost a decade of experience in the industry and has multiple times held the title of New England Women's Tree Climbing Champion, which I think is especially amazing. And I need to see the tree climbing championships at some point. Stella holds a master's of forestry from Michigan Technological University and was honored to have her research supported by the Hyland R. Johns Grant in 2022. So Stella, thank you so much for taking Hyland's name and carrying it into the future with the research you're doing, especially things like pruning regimens are something we think about every day with our customers, and it's very important. So thank you for the research, and thanks everyone for the opportunity to introduce Stella.
Okay, thank you so much, Chase, for that wonderful introduction. Can everybody see that? Does that look clear? Okay. Thank you so much to everybody for being here today. Thank you to Tree Fund for having me, as well as for your generous support of the research I'm about to discuss. We're going to be discussing pruning today, specifically its varied effects, including the ecological, physiological, mechanical, and carbon accounting effects of different pruning regimens, specifically reduction versus removal cuts of varying severities. We'll be getting into that more in a bit, but first I just want to point out that I've created these icons for you because there's a lot of material and hopefully these will help you stay oriented. Before we get into the pruning done by humans, I want to put pruning in the context of the varied forms of wounding to which trees are adapted. We could consider the kinds of pruning or wounding done by wind, ice, and snow to be abiotic pruning. And of course, we are not the only creatures that wound trees. A type of biotic pruning could be considered that by caterpillars or by elephants. And these different agents have different effects. So in this study, they found that the defoliation or removal of leaves caused by caterpillars had actually the opposite effect on shoot regrowth in mopane trees than the removal of more woody biomass caused by elephants. In this case, the removal of more woody biomass created longer shoots, whereas defoliation by caterpillars caused shorter shoots in the regrowth. We don't have elephants here in Amherst, Massachusetts. Ambient temperature 25 degrees Fahrenheit, around -4 degrees Celsius, I believe. But we do have white-tailed deer. And I want to draw your attention to the fact that these different biotic agents have different seasonal patterns, and trees are also adapted to this. So for example, invertebrates like caterpillars in our climate are typically more active during the growing season, while a mammal like a white-tailed deer prunes year-round. Humans, like other mammals, are also active year-round, and these different seasonal differences in pruning or potential seasonal differences in pruning response are something we're going to get into later. As we discuss this, I want to ask you all a question, which is which do you think came first in evolutionary time, beetles or flowering plants? And you can just put an answer in the chat. I can't actually see the chat right now. This is mostly for you. So just think about it and write down which you think came first. It'll be fun, hopefully, for you all. So those of you who said beetles are correct. Beetles and hymenopterans evolved in the Permian around 250 to 300 million years ago, and flowering plants evolved in the Cretaceous and Jurassic around 100 million years later. I draw your attention to this because I want to point out that trees have co-evolved with these different forms of biotic wounding for a very long time. We are here in the now. Now, one way that we'd like to think our pruning is different from that of other mammals is that we're more systematic. And this is one of the systems we use. This is the ISA Best Management Practice, or BMP, for pruning. And this is what we followed in this experiment. So in our study following the BMP, we looked at both removal cuts, which is removing a smaller branch back to a larger branch, in this case, what we would call a primary branch back to the trunk, and reduction cuts, which is removing a larger branch back to a smaller branch, at least a third of its diameter. For severity, we used cross-sectional area pruned. So we added up all of the different areas of these primary branches and took the percent of that we pruned as the cross-sectional area. You'll see this referred to as CSAP in graphs. That's a measurement of severity. Now, the BMP does point out that there may be differences in these two cut types, that removal cuts may be more likely than reduction cuts to allow the tree's branch protection zone to work. The BMP also points out that trees may not always compartmentalize reduction cut wounds as well as trees from branch removal cuts. However, this guidance, I would say, is based on science that still leaves a lot, there's a lot to be discovered. And that's one of the holes that we were attempting to fill with this study. One of the primary response variables we were hoping to measure is leaf area index, which broadly speaking is the amount of sunlight blocked by leaves and branches by trees. This is a good proxy for various ecosystem services trees provide, including shade and energy savings and things like that. Tree Fund had generously allowed us to purchase one of these devices. This is a LICOR device. And you see me using this in the research plot where the work took place. This included 3 species of trees commonly planted in urban environments around here, including Tilia cordata, Ulmus americana, and Fraxinus pennsylvanica. Unfortunately, this was in 2022, and the LICOR was subject to shipping delays due to the COVID-19 pandemic. This was going to set the research back by a whole year. I was a young PhD student. I was very concerned about this. I felt very responsible to Tree Fund for this work, and I was very stressed. So I was wondering what to do. This device wasn't going to be there on time. It was going to set a 2-year grant back by a year, which felt like a lot. And I reached out to my committee, and one of the members of my committee, Dr. Mike Cunningham-Minnick, suggested that instead of measuring the leaf area index of a primary round of trees, that we actually measure the invertebrate response. So Mike suggested that we hang yellow sticky traps, that we prune half the trees that we were planning on pruning, hang these yellow sticky traps to measure invertebrate response, and then just see what happened. So that's exactly what we did. We pruned about half the trees in September 2022, hung these yellow sticky traps to sample the invertebrates, and then counted the invertebrates that were attracted to the different trees. These are the initial results from fall 2022. These are graphs that Mike made, and these results, I would say they stopped us in our tracks. They made us say, whoa, there was something very exciting, very unexpected, and this suddenly pivoted from a pilot project to a critical piece of the work. So here you see that there were significantly more herbivores, what we would, from a tree perspective, call insect pests, on pruned trees than on the unpruned control trees. What's more, this effect was variable by cut type. So you see here that there were significantly more herbivores on trees subject to reduction cuts than those trees that had been subject to removal cuts. We also looked at the ratio of predatory to herbivorous invertebrates, and it was a very similar story with that. So if this ratio is higher, that means there were more predatory invertebrates, or what we would consider beneficial invertebrates, again, from a tree perspective, on the tree. And if this number is lower, as it was on pruned trees, that means there's more herbivorous invertebrates for every predatory invertebrate. This is something, again, from a tree perspective, we typically would not want to see. And again, we could see this effect by cut type, where the predatory to herbivorous invertebrate ratio was significantly lower on trees subject to reduction cuts than on trees subject to removal cuts. With that in mind, that was now a huge piece of this work, this is what the general timeline for the work looked like. We pruned the first batch of trees in September 2022, hung that first batch of insect traps in November 2022, pruned 19 more trees in February 2023. After pruning the trees, we conducted biomechanical tests, which I'll get into a bit later, and then measured the invertebrates 3 more times in the summer. The lichor had finally arrived, so we weren't able to get pre-pruning measurements, but did our work based on post-pruning LAI measurements. The following year, we measured epicormic regrowth, or suckers, or water sprouts, or shoots, and wound occlusion, woundwood. Feel free to put more synonyms for these things in the chats. I'll get into what I mean by them later, but I know they're called many different things in the industry. The following summer, we hung 2 more rounds of insect traps. And then the following winter measured epicormic regrowth and wound occlusion once more. This brought our total number of invertebrate measurements to 6. This is Athena Vassilopoulos. They were an amazing undergraduate research assistant who counted over 30,000 invertebrates, 178 traps total. The average number of herbivorous invertebrates was 142, and there were 31 average predatory invertebrates per trap. These invertebrates were from a wide range of taxa, not just functional groups. The biggest was dipteran, or flies. I bring up this graph just to show you that there was no overrepresentation of any particular taxa. And our overall results corroborated those initial findings. So this is based on all 30,000 invertebrates, and it showed that across species and across years, there were significantly more herbivorous invertebrates on pruned trees. This paper has recently been published in Urban Forestry and Urban Greening. You can find it here and also with the QR code here. I've added arrows to the slides with graphs to show you which direction we would typically want the graph to go, again, from a tree perspective, what we're looking for, because there are a lot of graphs and I realize that they can all start to look the same. You're also welcome to take pictures. However, there was not a significant or extreme relationship here between the amount pruned, the severity, and the abundance of herbivores. This was not a significant relationship, although it was weakly positive. I find this to be reassuring, again, from a tree health perspective. In those instances when severe pruning is either desired, such as in various types of ornamental pruning, like espalier, or required, as in utility pruning or storm damage. To reiterate, there were more herbivores on pruned trees than unpruned trees, and the number did increase with the percent pruned. However, the fact of pruning was much more important than the relative amount from a statistical perspective. And once again, our overall findings across those 30,000 invertebrates, I'm sorry, this is just season 1. Okay, so our overall findings did corroborate those initial findings that cut type was significant. By season 1 here, I mean the first 4 rounds of traps. So that is fall 2022, and then the following summer, June, July, August. In that first season, those 4 rounds of traps, there were significantly more herbivores on trees subject to reduction cuts than on trees subject to removal cuts, and both had more than the unpruned trees. However, this effect did appear to dissipate over time. So you see that this is still a significant relationship across all 6 sampling periods, but it's less stark and less obvious that there were more herbivores on trees subject to reduction cuts than those unpruned trees. What's more is this was primarily driven by the reduction to cuts on Tilia cordata, so this effect appears to be both species and time dependent. Now, there is some precedent for this work, especially with respect to the attraction of elm bark beetles to cut limbs on elm. And there is also work suggesting that pruning, even in the dormant season, can influence invertebrate dynamics the following growing season. This is work done by a team looking at pruning peaches in the winter, and they found that higher pruning severities, indicated here, increased the infestation of aphids, herbivores, the following growing season more than lower intensity pruning did. However, what we found with the cut type is very, very new, as well as the cross-species finding. Okay, so what could be driving this? Why is this? We wondered if any of the physiological responses to pruning that we looked at could also be explanatory in terms of the response we saw with invertebrates. So here is wound occlusion. This is what we called wound occlusion. We measured the relative percent of this. Again, feel free to put some synonyms or translations into other languages in the chat. And this is epicormic regrowth or suckers. We measured all those epicormic shoots within 20 centimeters of the pruning cut, as did prior researchers. And another just quick poll. This is the last audience participation till the Q&A. Do you feel like you can control these factors by how you prune, specifically epicormic regrowth and wound occlusion? Just write us a quick yes or no in the chat. If you don't prune professionally, I'm sure you've pruned something at some point. Again, I can't see the chat, so I'm just going to give you a quick minute to say yes or no. Yes, I can control this somewhat or completely, or no, I cannot control these responses by cut type or season or some other way. Well, so past research would suggest that you cannot. At least not if you're looking at reduction versus removal pruning. So work by Finney and team found that there were no significant differences between removal and reduction cuts in terms of the number of more than one epicormic shoot. And our results corroborated that. So we found that species was statistically significant and the primary driver of the number of epicormic shoots, but that the cut type, specifically reduction versus removal, was not. However, we did see an apparent slight visual effect that was not statistically significant, but a slightly increased number of apparent epicormic shoots with reduction cuts. And you see that in the Finney data as well. I would say, therefore, that this warrants future investigation, but I feel somewhat confident saying that species is the primary driver of this. We did not find any effect of season pruned. With respect to wound occlusion, or the percent wound occlusion, similarly, we found that species was the primary driver of this effect. There was, again, a slight visual indicator that there may be more wound occlusion in some instances on removal cuts. That would be in line with the BMP, but this was not a statistically significant effect. Species was the primary driver. Once again, seasonality of pruning did not influence wound occlusion. Okay, and I'm going to start to sound like a broken record here, but the average leaf area index, also species was the primary driver. There is a slight, again, visual indicator that perhaps reduction cuts may decrease leaf area index more. That was not statistically significant, but it would be in line with past research by Dr. Dan Burcham that suggests that. And seasonality, once again, was not a significant factor. This is included in the paper on the invertebrate results, if anybody wants to read that. Okay, so what do people notice about these? You could put something in the chat if you want to, but I was more thinking you just think in your heads about it. Because I think these two graphs are really interesting side by side. What I notice looking at these is that they're inverses. So here we have Ulmus americana, the elms, had the most epicormic regrowth and the least wound occlusion across cut types. And here we find that Fraxinus pennsylvanica, the ashes, had the most wound occlusion and least epicormic shoots across cut types. In other words, the graphs are exact inverses. To me, this suggests that species appear to prioritize one or the other, and that there may be physiological trade-offs with ecological consequences. I also think this is especially interesting in light of apparent tree vigor and tree health in the research plot. The ashes were suffering from emerald ash borer, EAB. The elms, I would not classify as totally healthy. There's spindle gall, there's some bacterial wet wood. And these responses did not, on a species level, interspecies level, did not appear to suggest these differences in tree vigor or tree health. So speaking of vigor, there's something called the plant vigor hypothesis, which states that abundant plant growth fosters a beneficial environment for invertebrate activity. Now, if this were true in our data, we would expect those trees with the most epicormic shoots and the highest leaf area index to have the most herbivores, the most herbivorous insects. This was not supported by our data. Neither the number of shoots nor the leaf area index was a significant predictor of the number of herbivorous invertebrates. Okay, so what about the predators? Remember that we also looked at the ratio of predatory to herbivorous invertebrates. Once again, our overall findings from those 30,000 invertebrates and 6 sampling periods suggested that there were significantly fewer predators of insect pests relative to herbivorous insects on pruned trees. That predator to herbivore ratio was lower on the pruned trees. Similarly, the effect was driven by reduction cuts, again, with less predators for every herbivore on those trees that had been subject to reduction cuts. And that it once again slowly dissipated over the course of the 2 years, despite being significant across those 2 years. In summary, we can say that pruning decreased the predator to herbivore ratio due to the differences between reduction cuts versus unpruned trees. There were less predators to eat the herbivores, especially on those trees that had been subject to reduction cuts. So what are the management implications of all this? I would say, first and foremost, don't panic. Secondly, I would say Once again, reiterate, do not panic. There is no need to conduct automatic IPM treatments on pruned trees or anything of that sort. But we have very compelling evidence that this effect likely exists. It may be a reason to stretch pruning intervals longer than 2 years in some cases, and to think carefully about pruning. I'm not saying not to do it. I'm just saying to think carefully about it, especially reduction cuts if tree health is already compromised. I also want to point out that we've been mostly talking about this from a tree perspective because we're tree people. This is the tree fund. However, we're in a biodiversity crisis, especially with respect to invertebrates and insects. And I think this likely effect of an increased number of invertebrates on pruned trees could be a selling point for pruning in some cases, especially when that pruning is required. Moreover, when we're talking about invertebrates, we're not just talking about invertebrates, we're talking about our food supply, our birds, our urban bats. This is a very interesting paper that was brought to my attention about urban bats. We're talking about all these other food chains and all these other organisms. And I really want to caution us that higher invertebrate populations are actually a good thing in many cases. I also want to reiterate that the ISA BMP doesn't currently mention invertebrates, and the typical focus is on decay. This is very new information, and thank you so much to the Tree Fund for allowing us to look into this. I also want to just bring this back and state that we should approach all of this with as much humility as we can muster, because these relationships between trees and their invertebrate pests, the invertebrate predators, are very, very old, and we are the newcomers to this whole scene. Okay, so you may be sitting there thinking, I thought we were going to discuss biomechanics and carbon. The clock is ticking. This is maybe for some of you, this is what you came for, and we will do that. So take a deep breath. We're going to change gears. It's going to feel a little abrupt, and then I'll try to bring it all together at the end. So for our mechanical methods, we tested damping ratio and sway frequency using dynamic pluck tests. We measured prior to and immediately following pruning. This was leaf on in many cases, although this demo is leaf off. In general, a higher sway frequency and a higher damping ratio are considered to decrease likelihood of failure under dynamic loads such as wind. Damping ratio in particular can be thought of as the efficiency with which a tree dissipates wind energy. I think the best explanation for damping ratio I've heard is when you think about a door, they put those dampers on. So if you slam a door really quickly, just a normal door without a damper, that would have a very low damping ratio. Whereas if you put one of those dampers on, that would have a high damping ratio. Okay, so we had devices to measure the sway called accelerometers and record that, and then derive these numbers from that. Past work looking at this has suggested that reduction cuts, you see here the undashed line is reduction cuts, and the dashed line is removal cuts, that those reduction cuts increased sway frequency across 2 species of trees, Senegal mahogany and rain tree, whereas removal pruning, these dashed lines, did not change sway frequency. Removal pruning also did not change damping ratio. This reduction pruning did decrease the damping ratio, which we typically don't want at severities higher than 20%. This work was conducted by my fantastic thesis advisor, Dr. Brian Kane, and his past PhD student, Dr. Dan Burcham. Our results were not incompatible with these results, but were also not identical. So our results suggested that pruning can increase sway frequency. This is a graph of sway frequency here, but it was species dependent. It did not appear to do this in Fraxinus pennsylvanica, in the ash. Oh, I meant to mention this prior, that we were somewhat limited in the number of trees subject to reduction cuts in the ash. This was for reasons of tree morphology. and very low sample sizes in reduction cuts in the ash may have influenced some of this. And you also see this visual effect in the elm. However, there were no differences between cut type. This was unlike what Dr. Dan Burcham found in that ability of pruning to increase sway frequency. So you see here, again, this appeared to be species dependent, with differences in Tilia and ulmus, but not in Fraxinus. Now, I say that our results are not incompatible with those of Dr. Burcham because the location of material that is removed matters greatly when it comes to biomechanics. This is a little technical, and we feel free to email me about this if people have questions, but this is due to the behavior of MDOF systems. And ultimately, it's because height is a factor and length is a factor in calculating the sway properties of these different structures, such as trees or branches. And we removed material differently. So when Dr. Dan Burcham was doing reduction cuts, he was kind of tucking the whole tree in. I wanted the reduction cuts to be more similar to the removal pruning, so I worked from the bottom up. So these differences could have explained some of the differences that we ended up finding. I should also point out that Dr. Burcham pruned to much greater severities, up to 80%. Okay, there was also a significant impact of severity on average sway frequency. Although you see from the data is pretty messy, which we'll get into is normal for these response variables, where higher severity did appear to adversely, higher severity did appear to increase sway frequency more, which is typically what we'd be looking for. Pruning, again in line with Dr. Burcham's result, did appear to adversely impact damping ratio in some cases. But overall, damping ratio is chaotic and determined by many factors. Severity was not significant here. This is my wonderful undergraduate research assistant, Jeffrey Dufour. This is another graph of damping ratio, this time versus tree height. And I just wanted to expose you all to this. This is data from buildings. Damping ratio, just to point out that damping ratio is frequently very messy and complicated, even in things that we might consider simpler because they're human engineered, for example, buildings. You see kind of some similarities in these graphs, but the underlying data is once again kind of all over the place. I also want to introduce you all to this very speculative concept, which is that branches could be tuned mass dampers. So tuned mass dampers are a small mass designed to limit the displacement or sway of a larger mass. The most famous example in a building is probably Taipei 101. This is designed to limit the sway of the building in an earthquake zone. It is speculative. However, we can assume trees grow within their own best interest most of the time. And other people have also proposed this. This is not my own idea. And I think an important thing to bear in mind is this idea has neither been proven nor disproven. It is mathematically, this paper points out that it is mathematically plausible that branches, the mass of branches works to limit the sway of the main stem and that trees allocate mass for that reason, but it has not yet been fully demonstrated. Neither has it been disproven. I also want to raise the point that the biggest impact on mechanical properties is leaf loss. So here is a subsample of our data, and this is the average pre-pruning frequency. You see a slight increase pre-pruning to post-pruning, and then this is winter when there's no leaves, and you see a big jump in frequency. Similar damping ratio, you have an average pre-pruning damping ratio from a subsample, average post-pruning slightly decreases damping ratio, and then leaf off damping really drops it further. So I would say this is something that is known. We do have some confidence around this, that the biggest impact on the mechanical properties in a temperate climate, such as here in Amherst, Massachusetts, is seasonal leaf loss, as opposed to pruning at industry standard severities. Okay, so CO2. The tree care industry emissions are about 7 times higher than other industries of similar size. Again, we are in that climate crisis that I was talking about earlier, and we need to reduce this where we can. This is excellent work conducted by Luck and team in the UK. This is a doctoral dissertation. And here you see arisings, that is, wood waste composes the vast majority of our CO2 contribution, followed by working vehicles. So we did do a little bit of looking into this and found that these are our results. This is Jeffrey again, weighing branches. Found that species is very, very, very important when considering the total carbon removed. Ulmus americana represented much more carbon on average than the other two species. This is due to very different relationships between diameter and length of branches across species. Reduction versus removal cuts, you see here, it appears that the average carbon removed for reduction cuts in elms was even higher than removal cuts. I think the take-home point here is that smaller individual cuts do not necessarily mean smaller overall amounts. Okay, in a practice version of this talk, some feedback was this felt very random, and I will admit this was a bit of a pilot study. We just needed to chip some brush to make some space in there. And so we had Sean Walker and Mike Carlson come out, colleagues of mine here at UMass, and I timed them while they were chipping. And we found that both the distance to the chipper and the amount in terms of cross-sectional area were significant predictors of chipping time, but distance to the chipper was more important. Here we have just a reminder that these non-road diesel engines, like chippers, are actually a relatively smaller amount of our sectoral contributions, but again, move that chipper closer where you can. Okay, so to pull out some kind of key points of all of this, starting to bring this all together. In terms of the 2-year response to pruning, the severity in terms of the cross-sectional area, percent cross-sectional area pruned, was in general the least important predictor of these various response variables. Pruning cut type was more important actually in many cases, including with the invertebrates. The fact of pruning was highly, highly, highly significant, again, especially with respect to the invertebrates. And then species is absolutely huge. Species drives so much of response, especially physiological response. We did not find compelling evidence to support differences in seasonality of pruning. That is the Northern Hemisphere September versus the Northern Hemisphere February. And I think we should not be altogether surprised by this. I think there's a solid case to be made that, for example, liquid ambar and ginkgo, sweet gum and ginkgo, are more different evolutionarily than humans and bats. I was not going to compare anyone else to a bat. This is me. We are more similar to bats by over 100 million years than these two trees are similar to each other. And I would hope that a medical doctor would take the differences between me and a bat with some seriousness. I think we as arborists should take seriously the differences between these tree species, even those that are more similar than ginkgo and sweet gum. Again, these species of trees have been diversifying for a very long time. We didn't even address gymnosperms such as pine trees. I think this question of the fact that gymnosperms actually preceded a lot of this evolutionary development of various invertebrate taxa is really interesting. I think extending this work to gymnosperms would be really interesting. We did not do that. And these trees have also undergone a long, hundreds of millions of years of coevolution with these different herbivores. Overall management implications. Pruning increases the amount of herbivorous invertebrates and decreases the number of predatory invertebrates for every herbivore associated with a tree. Whoa, this is huge. This is the biggest thing we found. It is, again, in many ways, very, very, very new, and I think there's a lot of jumping off points here for future research. Physiological terms, the amount of epicormic regrowth and wound occlusion are largely driven by species, not cut type or severity. With respect to the carbon, any pruning has a carbon cost. I think we can mitigate through mindful use of pruning as a treatment and moving chipping close where possible. In terms of the mechanical effects, it is very species dependent and possibly cut type dependent, but standard pruning probably has a mildly beneficial effect on sway frequency and a mildly adverse effect on damping ratio. Again, species is majorly important in response to pruning. I hope you all take that away. Low severity pruning still has many, many impacts. High severity pruning does not appear to have exponentially greater impacts, although it does have slightly greater impacts in terms of some response variables. It is not exponential by any means. I think this is highly relevant for storm damage, ornamental pruning, pollarding, utility pruning, things of that sort. Just a reminder that pruning usually benefits people, not tree health, so deploy thoughtfully. Any intervention, including pruning, is about interspecies coexistence, and context is everything. The cut type in terms of reduction versus removal pruning does matter, but again, there is no one right answer. It depends on your goals and your concerns. In other words, this requires us to use our brains, which is great. It's so fun to use our brains. And I just want to reiterate that context is everything. There is no one right answer, but keep in mind that when we're talking about pruning, we're talking about many species and many variables. Okay, and again, circling back, we are activating processes that predate us that are very complex. This is where researchers put luminescence onto calcium ions to show the plant response to a caterpillar chewing on a plant. And this is what happens. There's the little caterpillar chewing. There's that signal getting spread through the plant. And this is the kind of thing that we're doing when we prune. We're just going to watch that again because it's so neat. And the link is here if you want to go look it up on your own. There are more very long-term speculative questions and research implications. I think there are big questions here with respect to the ability of pruning to induce systemic acquired resistance and its interaction with other stressors. That is, does past pruning influence the tree's response to future pruning? Or does past pruning, even minor pruning, impact the tree's defense system in such a way that perhaps that tree is even more resilient in the face of future insect attack or future drought, things of that nature, what we would call priming. There's questions here with respect to epigenetic changes and possibility caused by pruning, including potential mechanisms whereby that would be heritable. And of course, volatile organic compound signaling, what is going on? Why is this effect that we found with herbivores and predatory invertebrates and bugs and insects of various sorts happening? They didn't set me up. I wasn't in communication with Bo and Heath about this, but please consider supporting Tree Fund so that we can answer these questions. It truly is a really, really, really important source of funding. And there's so much here that is so interesting. There's so much interesting here that is so applied. And please consider supporting Tree Fund. Really couldn't do it without them. Speaking of people, we can't, and institutions, organizations that we couldn't do this work without. Thank you so much to the Garden Club of America, New England ISA, the Bartlett Foundation, the Massachusetts Tree Wardens and Foresters Association, both for their funding assistance as well as for hosting a prior version of this talk. UMass Amherst Facilities and Campus Services for all of their support. This was all conducted in the Waugh Arboretum. And then thank you to all the people. This is just a subsample. Dr. Brian Kane, Dr. Michael Cunningham-Minnick, Christina Bezanson, Athena Vasilopoulos, Jeffrey Dufour, Lily Reeves, Hannah Bruno, Audrey Kissin, Sean Walker, Mike Carlson, Brady Yasek, Todd Kornoyer, Mike Amato, Dr. Sanjay Arwade, Dr. Dan Herms, Dr. Michelle DaCosta, Lindsay Watkins for that picture on the first page, Neil Gehring, Tess Sarnacki, who's monitoring the Q&A, Inda Shane and Michael D, Molly Kavanaugh, John Madison, Sean Comer, and all the crew leaders and members who trained me. And last but certainly not least, Pamela Mon.
Well, Stella, you are ready to win an Oscar someday. That was fantastic. So, thank you very much. We do have some time to take some questions. I know Tess, you were on there. If you are able to help pull out some of those questions, or Bo, if you do as well.
Yeah,
Yeah,
absolutely.
Oh, sorry, Bo.
No, you go ahead. Go ahead, Tess. I was just going to say real quick, Stella, fantastic research. And to all of y'all listening out there, this was just, I mean, I really liked you connecting how this research will trickle down into the best management practices. And just as a reminder of, we have seen that at Tree Fund. We will continue to see that at Tree Fund. And I think we couldn't have asked for a better presentation. So, but anyway, into the Q&A. Tess, if you have the first question, cue it up.
Ready to go. So I tried to sort of summarize a few questions into one, but there were a lot of questions and comments about open grown trees versus forest grown trees, and how this research sort of reaches into that. So it might be maybe a good helpful for you to just sort of summarize how your research relates or how you connected to those two different growing environments.
Yeah, thank you so much for that question. That's a really great question. Could I share my screen again actually? Because
Absolutely, you can steal it back.
can I steal it back? Because I think um I I know my tree people. I like to think I kind of know my tree people, and I did sort of anticipate something of this nature might be brought up. So I'm gonna soft launch our further results. So okay, so to answer the question, I think these species were chosen because they are commonly planted, open grown species. You are correct that many of them were not open grown per se. So the following study that we completed over that I completed over the next 2 years, 2024 to 2025, we looked at 89 honey locusts across three growing zones. And the preliminary results of that, this was across the Northeast. The preliminary results of that substantiate the findings with respect to herbivory. This is highly classified. I mean, obviously it's not highly classified. There's like 1,000 people here. But it is preliminary. But our preliminary results confirm our findings. I think it is true that the magnitude of some of these response variables would be different in open grown trees. What you see here is this is the research plot. So these are honey locusts in the research plot. And you see far more herbivores in that forested environment. But the directionality of these responses are identical. So I believe that the difference between open grown and again, these honey locusts were a wide variety of sizes and growing conditions. I think the overall directionality would of these different response variables would not change, but the magnitude certainly would. Again, context is everything. If you don't mind, Tess, I'm also actually just going to quickly answer this Fraxinus question because I think it's really good. Why was Fraxinus pennsylvanica used during the fall 2022 due to the guarantee of EAB? Because of that, essentially. I think in an urban environment, we do work with trees that are highly stressed. And so there were a couple aspects here. First, it was trying to get some information out of these trees before they all started falling over, which happened over the course of this experiment. And the second was to look at how stressed trees respond. And I think it was very interesting. Again, they did have the most wound occlusion. I think often people are taught that that amount of wound occlusion is greater in more vigorous or healthier trees. And I think it's a very interesting finding that was enabled by that choice to find that actually the most wound occlusion was in arguably the least healthy trees.
Stella, there was a couple questions about the ratio of pruned wood being the same for trees receiving the reduction cuts versus the removal cuts, and also the max diameter that y'all were pruning. And this was in relation to the insect part of this first part of your study.
Yeah, so originally, broadly speaking, both the reduction and the removal treatments were targeted at around 20% and around 40% of cross-sectional area. I ended up using the exact numbers for that for a range of reasons, but generally we were looking at lower severity and higher severity pruning. So those average percentages of severity were the same for both reduction and removal cuts. The maximum diameter varied by species and morphology, but was quite large in terms of cuts. I think the biggest cut I made was probably oh probably 6 to 8 inches diameter. So pretty large. I apologize. I did all the analysis in metric, but I'm hopelessly English. Yeah, so it was pretty large. The highest severity was around 55% overshooting that 40%. I ended up, yeah. Feel free to email me about that if you want more specs.
If we have time for another question, I think I have one that kind of rolls everything together. There's been a lot of I talk and questions about like what sort of implications this work has when we are pruning or thinking about pruning populations of trees that have some sort of susceptibility to disease or already, like in the case of EAB, where the trees were already infected. And I guess a summary of the question is like, should we just not prune those trees to reduce vectors, or, what are your thoughts on that?
Yeah, I think my thoughts are that's not for me to say. Again, context is everything. You know your context best. I hope that the information provided here is helpful to you, but you know your situation, you know your species, you know your climate, you know your client, you know yourself and your own understanding of what's happening. So that's not ever a question I don't think that research is going to be able to answer for you. We can only support you with different pros and cons and information. And consider supporting tree funds so that we can continue to do that. But that is your decision. Think about the context holistically, is what I would say.
I think that's a great answer, and I think that brings us to the top of the hour. Thank you, Stella, for a great presentation. Thank you, Tess, for helping us with the Q&A and kind of wrapping that up. I think that's a great way. I think a lot of y'all have some good food for thought for the holidays, kind of one more item to add to your checklist when you're evaluating when to prune, why to prune. And I think this is great. Just as a reminder, please remember to support Tree Fund as we move into the holidays. And also the great news that with the new Hyland Johns being endowed in the way of $500,000 from Asplund. So that is also really good news. But thank you all. Have a great holidays. And I'll leave the final word to Heath to wrap us up
Yes,
with the
thank you.
webinar news.
Thank you for all those that have supported throughout this webinar. We greatly appreciate it. As a final housekeeping rule, we will be submitting your CEUs to ISA, and then probably in a week we will have this on our webinars archive page. We might send some of the unanswered questions to Stella, so be sure to check Tree Fund's webinar archive page for both the link and some of the questions that were left unanswered. So thank you, everybody. Stay cool, stay warm wherever you may be, and we'll see you in 2026 with a great lineup of more Tree Fund webinars. Thank you.
Cheers all.